Hey everyone, we're going to continue on with vectors. We're going to do some addition and subtraction, scalar multiplication. We'll talk about properties of vectors, and then we'll talk about the unit vector. So let's go ahead and get started with adding and subtracting. And this again is the note sheet, so make sure you have it printed off. Okay, and this might be a little hard to read when you're looking in this box here. This is A1 plus A2. And then B1 plus B2. That's what that says there. Likewise for subtraction, A1 minus A2 and then B1 minus B2. So you're adding or subtracting the A's and then the B's in order to get the addition of two vectors or the subtraction. So let me show you really quickly what I mean by that. If V is 5i plus 4j and W is 6i minus 9j, find V plus W and V minus W. So V plus W is, all I'm going to do is I'm going to add my I. So I have 5 plus 6 I plus, and then we have 4 minus 9 J, J. And so that gives us 11 I minus 5j. That would be minus 5j. And for V minus W, if I go ahead and do that, I'm doing 5 minus 6 I plus 4 minus a negative 9, 4 minus negative 9 j, and that would give us negative I plus 13j. Okay, so that's pretty straightforward. You're just adding the components of I and the components of j, or subtracting the components of I and the components of j. Okay, let's talk about scalar multiplication. Scalar multiplication is taking any real number, k, and then you're multiplying it by your vector. And so you'll see here in the formula, we're just multiplying that a value and the b value by that scalar multiple, or that k value. Okay, so if I have the vector 5i plus 4j, I want to find 6v, then all I'm doing is multiplying 6 times the 5 to get the I, and then 6 times the 4 to get the j value. So that would just be 30I plus 24j. And if I'm doing negative 8v, remember a negative changes the direction, changes it, puts it in the opposite direction, and then the 8 is our scalar value there. So if I do the same thing, I have negative 8 times 5I plus negative 8 times the 4j, so that would give me negative 40I minus 32j. Okay. And another example of how we would do that, here we're doing 4v minus 2w. So we've got 4v minus 2w. And hopefully you can see here that this is really the same as just doing the distributive property of k across the entire vector. So I can think of this as 4 times 5i plus 4j minus 2 times 6i minus 9j. Kind of went off the white there. And if we just distribute, that gives us 20i plus 16j minus 12i plus 18j. And if we combine our like terms there, we end up with 8i plus 34j. Excuse my really bad handwriting today. Okay, so that's the idea behind that. Pretty straightforward stuff. Okay, a couple quick things, and then we'll wrap this up. This is going to be a little bit on the shorter side, which I'm sure you're happy about. The 0 vector has a magnitude of 0 and is assigned no direction, so that's important to note. And then we've got all of these different properties. If we're given u, v, and w are vectors, c and d are scalars, then the following properties are true. Okay, so those properties, and you guys know these properties already, right? This first property is the commutative. And if I try to write all these in, I'm sure I'm going to mess it up because there isn't a lot of room. So I'll just abbreviate. That's the commutative property, commutative. The second one, when you just change the grouping, is the associative property. This is the additive identity. Additive identity, right? If you add 0 to anything, you just get back what you started with. And number 4 is the additive inverse. And these are all listed in your book, but I like to put them here so that you can refer to them. The multiplication properties, right? This is associative. This one's distributive. This one is also distributive. This is multiplicative property of 1. This is the multiplication property of 0. And that last one you see there is called a magnitude property. Okay, so if I have CV, C is your scalar. So you take the absolute value of that, and then you find the length of V, or the magnitude of V. Okay. The point of all this is that basically what you do with regular numbers, you can do with vectors as well. Okay, and the last thing I want to talk about is the unit vector. A unit vector is defined as a vector whose magnitude is 1. And it's helpful to find the unit vector that has that same direction as the vector you're given. Okay, so that's going to be helpful. You'll see that when we get into tomorrow's lesson, when we start doing applications of vectors. But this is the formula that you're doing. So it's the vector over its magnitude is what we call the unit vector of that as a vector v. Okay, so let me go through an example. We want to find the unit vector in the same direction as v is equal to 5i minus 12j. So the first thing I have to do is I have to find that magnitude, or the magnitude of v. Remember, I do that by just doing the distance formula, or you can think of it as a squared plus b squared and then taking the square root of that. So if I go ahead and do that, I've got 5 squared plus 12 squared, which gives me 25 plus 144, which is 1 square root of 169, which comes out to be 13. And so when I find the unit vector, oops, that should be a v. When I find my unit vector, I would simply have 5i minus 12j over 13, which can be written as 5 over 13i minus 12 over 13j. And that is your unit vector for that given vector v. Okay, so that's the idea behind that. And that's all we're going to do for today. So hopefully that helps, and we'll catch you next time. Thanks, folks.